Hello again, class. Today we're going to look at section 8.2, dealing with zero and negative exponents. Our learning target today is we want to be able to evaluate powers that have zero or negative exponents. Now, in order to do that, we have a couple rules. First, let a be a non-zero number and let n be an integer, all right? A non-zero number to the zero power is 1. Okay, so any number you can think of, as long as it's not 0, raised to the power of 0 equals 1. So for instance, my favorite number is 11. 11 to the 0 power equals 1. My second favorite number is negative 243. Negative 243 to the 0 power equals 1. Alright, so any number other than 0 raised to the power of 0 equals 1. The second rule we need to learn is if we have a to some negative exponent, we just rewrite it. Now, if you have a number raised to a negative exponent, it does not necessarily mean it's a negative number, all right? It just means that we're in the wrong spot. I'll show you what I mean in just a second. Now, for this, we say if we have a to the negative nth power, we rewrite that as 1 over a to the nth power. So those are the two rules we're going to be using today. Let's see how we're going to use them. So example 1. 21 to the power of 0. Do yourself a favor, get your calculator, pause the video, and do 21 to the power of 0. What do you get? Spoiler alert, you're going to get 1. Okay, using that same calculator, use parentheses, do 2 divided by 5, close the parentheses, and then raise that to the power of 0. What do you get? 1. Alright? So any number other than 0 raised to the power of 0 equals 1. What about this case where we have a negative exponent? Let's say 4 to the negative second power. That does not mean negative 16. Okay? It doesn't mean a negative number. What that means is I need to rewrite it. So instead of 4 to the negative second, I'm going to rewrite this as 1 over 4 to the second. Okay? So a negative exponent just means it's in the wrong spot. Because really, we could rewrite this as 4 to the negative second over 1. And since we have a negative exponent in the numerator, and a negative exponent means we have the wrong spot, we just need to move that to the denominator. And then we can simplify just a little further. 1 over 4 squared is equal to 1 over 16. Example D. We have 1 over 3 to the negative third. Here's the thing. We have a negative exponent, which tells me that that's in the wrong spot. But this time that negative exponent is in the denominator. So let's move it up to the numerator. I'm going to rewrite this as 3 to the positive third power over 1. 3 to the third power equals 27. All right? So any number other than 0 raised to the power of 0 equals 1. And anytime you have a negative exponent, you know your number's in the wrong spot. If it's in the numerator, move it down to the denominator. If it's in the denominator, move it up to the numerator. Let's look at a couple checkpoint problems. Number 1, we have 2 to the power of 0. Any number other than 0 raised to the power of 0 equals 1. Number 2, we have negative 1 to the power of 0. Again, any number other than 0 raised to the power of 0 equals 1. And yes, I know it's negative, but still, a negative number raised to the power of 0 still equals positive 1. Number 3, we have 2 to the negative third power. Okay? If I wrote this 2 to the negative third power as 2 to the negative third over 1, you would see that, we have our negative exponent and that it's in the wrong place. So we're just going to rewrite it. Instead of 2 to the negative third power with that negative exponent in the numerator, I'm going to rewrite it in the denominator with a positive exponent and fill it in that placeholder with a 1. Then we can simplify a little further. We have 2 to the third power is 8. So our final answer would be 1/8. And last, number 4. Here we have a negative exponent in the denominator. Okay, negative exponent tells me it's in the wrong spot, so I need to move that up to the numerator. So this will be negative 8 to the positive second power over 1. Negative 8 squared is 64. If you wanted to, you could write your answer as 64 over 1, but 64 is more simplified. Great, let's keep moving. On to example 2. We'll break it up into a couple pieces here. Let's start with parts A and B. So, we're going to have to pull some knowledge from last section to complete these problems. Let's start with A. Here what we're doing is we're multiplying 2 to the 4th times 2 to the negative 4th. When we multiply two powers with the same base, we add the exponents. And we know that from the product of powers property. Now, that was from 8.1, hopefully you remember. Four plus negative 4 is 0. And then 2 raised to the power of 0 is 1, because any number not equal to 0 raised to the power of 0 equals 1. Part B. Here we have a power raised to another power. When we raise the power to another power, we multiply the exponents. Okay? That was the power of a power property. Negative 2 times negative 2 is a positive 4. And 3 to the 4th power equals 81. How about part C? This is probably the toughest one we've seen so far. We have negative 2 times 3 being raised to the negative 2nd power. Now, here's the thing. I see a negative exponent, and it's in the numerator. So what I'm going to do is I'm going to rewrite this with a positive exponent, and I'm going to move that. So it's in the numerator, it's in the wrong spot. So I'm going to rewrite it as negative 2 times 3. Now I can say to the positive second power. So, hopefully you remember that I need to apply this second power to every piece in here. So we're going to rewrite this as negative 2 squared times 3 squared. That was the power of a product property. Negative 2 squared is 4. 3 squared is 9. So we have 1 over 4 times 9, or 1 over 36. Let's try some checkpoint problems. So number 5, we have 7 to the 4th times 7 to the negative 4th. We're multiplying two powers with the same base. So I keep my base and I add my exponents. 4 plus negative 4 is 0. 7 to the power of 0 equals 1. Number 6, here we are raising a power to another power. So I keep my base and I multiply my exponents. That gives me 2 to the 4th power, because negative 2 times negative 2 is positive 4. 2 to the 4th is 16. last, number 7. Instead of writing negative 3 times 3 to the negative second power, we're going to change that to negative 3 times 3 to the positive second power. This gives me 1 over negative 3 squared times 3 squared, because we need to apply that second power to both terms. Negative 3 squared is 9. 3 squared is 9. So I end up with 1 over 9 times 9, or 1 over 81. All right. Let's move on to example 3. We're going to take these one at a time here. So, first, part A. So we have 3 times x to the negative 4th times y to the negative 5th. I want you to think of this as, give myself a little more room here. So if we have, fit this all in here. There we go. If we have 3x to the negative 4th, y to the negative 5th, I want you to think of that as 3 times x to the negative 4th times y to the negative 5th. Because then I can break it up, okay? So we'll have 3 times x to the negative 4th, which again, if we have a negative exponent, we just rewrite it as 1 over x to the 4th, times y to the negative 5th, which we can rewrite as 1 over y to the 5th. Hopefully you remember how to multiply fractions. We multiply all the numerators together, so 3 times 1 is 3. Then we multiply all the denominators together. 1 times x to the 4th times y to the 5th is x to the 4th, y to the 5th. Example B, a to the negative 1st divided by b to the negative 2nd. All right? Here's the thing. Both have negative exponents, okay? Both have negative exponents. So we are just going to flip where those are. So I'm going to skip all of this. A to the negative 1st. We have a negative exponent in the numerator, so I'm going to move it down to the denominator. B to the negative 2nd. We have a negative exponent in the denominator, so I'm going to move it up to the numerator. And that's our final answer. And example C, part C of example 3. Here we have 7c to the negative 2nd power. Okay, again, it's a negative exponent. I don't want to write with negative exponents, so I'm just going to change where it is. So I have 7c to the negative 2nd in the numerator. How about we rewrite that in the denominator? So how about instead of 1 over 7c to the positive 2nd power? Then we can use that power of a product property, where we apply that to both pieces. So we write this as 1 over 7 squared times c squared. Okay? That was the power of a product property. That leaves me with 1 over 7 squared is 49, c squared is c squared. Final answer. Let's look at 3 more, and then we will be done, okay? Let's look at 3 more. So checkpoints, number 8, let's start there. So think of it like this. I have 3 times c to the 7th times d to the negative 7th. Now, that d to the negative 7th, I can rewrite. Since it's a negative exponent, we write it as 1 over d to the 7th. And think of these all as fractions. Now, when we multiply fractions, we multiply all the numerators together. So 3 times c to the 7th times 1 is 3c to the 7th. And we multiply all the denominators together. 1 times 1 times d to the 7th is d to the 7th. That's my final answer. Number 9. Here we have a fraction, u to the negative 5th over b to the negative 3rd. And here's the thing. U to the negative 5th, I have a negative exponent in the numerator, which tells me it's in the wrong spot. So I'm going to move that down to the denominator and make it positive. V to the negative 3rd. Again, here we have a negative exponent, but it's in the denominator. It's in the wrong spot. So we move it up to the numerator. V to the 3rd. That's my final answer. And last, number 10, 3t to the negative 3rd power. I'm going to rewrite that as 1 over 3t to the positive 3rd power. Because again, negative exponent in the wrong spot, put it into the denominator. Apply that 3rd power to each piece. So 1 over 3 to the 3rd, t to the 3rd, leaving me with 1 over 27t to the 3rd. And that is section 8.2. Properties of exponents take a lot of practice, but once you get used to them, you'll be able to fly through these problems. Make sure to do your practice. Email me with any questions.